start talking about this. On number 1, where are the x-intercepts at? Where are the roots? Yep, -4, +2. Oh, I forgot the negative on the 4. And -3. And again, we find those by taking each of these sets of parentheses, like x plus 3, set it equal to 0, and then we solve it for x. I just keep writing down the wrong things. Sorry, guys. So that's how we got this. So far, so good? All right, so I'm going to go and plot those points first. Those are all going to go on the x-axis. So I'm going to have 1 over here, 1 right here, and 1 right here. No, here. So far, so good? All right. Now we need to figure out what our n's are doing. And we look where for that again? Leading coefficient. What is the leading coefficient? Positive. Right here. I don't see anything there, which means it's an invisible 1. 1 is the only number that's allowed to be invisible like that. So we have a positive leading coefficient, which means what? What's going up?
The right side.
Right side goes up. So I'm going to go to the dot that is farthest to the right, and I'm going to make it point up. Like this. So far, so good? Now I need to figure out what the left side is doing. I need to know the degree for that.
It's the invisible exponent.
Invisible exponents. They're all invisible, so they're all an invisible 1. So I've got a 1 here, a 1 here, a 1 here. It's odd. 1 plus 1 plus 1 equals 3. This is my degree. Does it always mean it's going down if it's odd?
No, it just means going the opposite way.
Yes, odd means that the left is opposite. So that means on this one, the left is going down, yes. And now we're looking at those little exponents again, because I really want to focus in on each one of these x-intercepts. I'm going to pretend that I can't see anything else in this picture except for one x-intercept at a time. If I couldn't see anything else but this right here, I realize you can hardly see that on my screen, but I really want to focus your attention. We're just looking at that one x-intercept. When it has a degree of 1, what's it going to look like right there? It's going to go through that x-intercept like a line. So it's going to go straight through it like a line. What about if I couldn't see anything on this graph except this x-intercept? Also looking like a line there, because that factor also had a little 1 for its exponent. And then I'm just looking at this one in the middle. This goes through like a line, this goes through like a line, but these all need to connect, right? So it's going to have to loop around so that it can touch it right there. It's going to go through this one like a line, and it's going to loop around there. Something like that. All right, let's go look at number 2. Start off with our x-intercepts here. How many x-intercepts do we have? 3. Where are they?
-3, 0, +1, 0, and 4, 0.
Yes. -3, 0, +1, 0, and 4, 0. Again, we take these, set them equal to 0, get the x all by itself, And that's how we're coming up with these x-intercepts. We do that for each one of these sets of parentheses. All right, so at -3, so I've got a dot there. I've got one at +1 and one at +4. What do I want to get on here next?
We got a leading coefficient, which is negative.
It's negative.
Yes, leading coefficient is negative.
So the right side's going down.
Correct. So we have a negative leading coefficient, right side goes down.
So we have a positive degree.
Degree is always positive. I think you used the wrong word, but right idea. It's even, yes. Right idea, I just think the wrong thing is what came out of your mouth. Negative leading coefficient, so right side goes down. I'm going to go over to the right side. It points down. Here we have a 2. The others are invisible ones. Yep, 2 + 1 + 1 is 4. There's my degree. That's an even number, right? So what does that mean about the left? It's going to go down also, because if it's even, it will do the same as the right side. So on this one, that means it's also going to go down. And then I'm going to look at each one of those x-intercepts. I'm going to focus on the one way over on the right first. What is the x-intercept that's farthest to the right? Yeah. Which one is that? Which one is farthest to the right? The 4. So I go look at that factor. It has a little 1 on it, so it goes through it like a line, right? So all the way through it like a line. Let's go look at the one all the way over on the left, though. Which one of these x-intercepts is the one that's farthest to the left? -3. Which factor did that one come from? This one right here. What's the exponent there? 2. Does it go through it like a line? It's going to look like what? It's going to look like a parabola. It's going to go up to the x-intercept, or up to that x-axis, and then it's going to bounce off of it. So if it's coming up from the bottom and then it bounces, it's going to bounce back down. What about right here? Does it bounce there? No. So these two are going to curve around, and it'll go through it like a line right there. This kind of a situation right here, again, that's coming because of this 2. This is called a double root.
What if it's a 3?
If it's a 3, it would have a weird squiggle through it, because that's what a cubic function looks like. We're not really going to deal with those in Algebra 2. Pre-calculus, you might see something like that come up. Yes. This is a double root. All right. Do you guys have any questions for me about the bell work? We are going to learn today how to take it from a big, long polynomial and put it into this factored form so that we could graph it like this, using the x-intercepts and that leading coefficient and the degree. So I want you guys to flip in your books to page 273. Page 273. We're going to use something called polynomial long division. Do you guys remember learning long division in elementary school? Yeah? So let's just revisit for a second what you remember about long division. Let's pretend we're doing 53 divided by 4. What's the first thing you look at?
5.
How many times 4 can go in? How many times can 4 go into 5? Once. So I put the 1 up on top.
Subtract 4 from 5.
How did you come up with 4? Why isn't it 8 or 12 or 15?
Because it's a little multiplication sign right after the point right there. So 4 times 4 is 4, so you bring 4 down. It's 5 minus 4.
Yes. You take whatever number you put up on top. How many times can it go in? You multiply that by out front. And then what do we do? Subtract.
And you get 13 because you bring in 3. You bring the 3 down.
Yes. This will be here. We bring the 3 down, and so we have a 13. And then we would keep going with that, right?
Mm-hmm.
How many times does 4 go into 13? 3 times. I'm not going to write it down because I'm going to run into all my stuff here. But you guys remember this long division process, right? Okay, so polynomial long division. This big long thing right here, this is the part that goes under our long division symbol. So I'm going to start off by writing that down. So I'm going to have x cubed plus 2x squared minus 23x minus 60 underneath a long division sign. What goes out in front will be a factor. So this guy right here, factors go out in front.
We have to set it to 0.
We do not have to set it equal to 0. I want the factor for my long division. Tomorrow we'll look at something where we do set it equal to 0. It's a way to do this process, but with only the numbers instead of the x's. So x plus 3 we have out in front. So far so good with how I've set it up? Do you guys remember when you were telling me about long division in elementary school, you said, how many times does 4 go into 5? And we wanted just the whole number of times. You could have said 5 divided by 4. Well, that goes in 1 whole time, right? And put that up on top. So I'm going to look at this x right here and this x cubed right here. And I'm going to kind of pull those off to the side. I want to know how many times does x go into x cubed, but that's kind of a weird question to ask. That is really over on the edge there. What happens if I do x cubed divided by x?
You get x squared.
X squared. This I put up on top. So I put x squared up on top. And then I take that x squared and I distribute it to the stuff in the front. Do you guys remember how you said take the 1 times the 4? We're doing the same thing, except I got 2 parts out front now. So I have to distribute to both pieces. What is x squared times x? That is x cubed. Notice these 2 things match. I need those 2 things to match because I want them to cancel. Okay? What is x squared times 3? 3x squared. What was the next thing that we did after we did the multiplying? What did you tell me to do? Subtract. I'm going to subtract this. How many things do I have here? 2. So how many things do I need to subtract? 2. I need to subtract both of them. Minus, minus. What is x cubed minus x cubed? 0. Cancels out. That piece in the front should cancel out when you do your subtraction. What is 2x squared minus 3x squared? Negative 1 x squared. There we go. Negative 1x squared. Bring these other 2 pieces down. This is just like where I stopped writing things down here. And you said we kind of start all over again, right? We go, how many times does 4 go into 13? So I'm going to start all over again here. I'm going to say, how many times does x go into negative 1x squared? So I'm going to pull those off to the side. Negative 1x squared divided by x. Negative 1x squared divided by x. What would that give me? What'd you say? Negative x, yes. Negative x is what I now put up on top. So minus x. What do you think I do with that now? Distribute that. Yes, we're going to take that and distribute to those two pieces out front. What is negative x times x?
Negative x squared.
Negative x squared. What is negative x times 3?
3x.
Negative 3x. After we distribute, what do we need to do? Subtract. How many things do I have here? 2 things. I've got this and I have this. I'm supposed to subtract them both, but they already have minuses in front. What happens when you subtract something that already has a minus? It becomes a positive. So I'm going to change this to a positive, and I'm going to change this to a positive. Both signs are going to change because I'm subtracting both things. What is negative 1x squared plus 1x squared? They cancel. What is negative 23x plus 3x? Negative 20x. And now I'm going to bring down this minus 60. Almost done. One more time. What am I comparing? The x and the, not the 3, negative 20x. Negative 20x. How many times does x go into negative 20x? 20 times. There's one other piece that I need, though. Negative. So I have a negative 20. This is what goes up on top. So minus 20. What do you think I need to do with that minus 20? Distribute it. Negative 20 times x. Negative 20x. Notice this front piece should always, 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 always match when I distribute. What is negative 20 times 3?
Negative 20 times 3.
Negative 20 times 3.
Negative 60.
Negative 60. Then what's going to happen to both signs? Both signs are going to change because I'm going to subtract what's there.
Both turn positive.
They're both going to turn positive, and now they cancel. Both pieces cancel, right? Here's my remainder. When you do your long division, your remainder should always come out to be a 0. If your remainder doesn't come out to be a 0, then somewhere earlier in the process you've made a mistake. Usually it's with remembering to change both signs when you do your subtraction part. Okay, so we're going to start writing it in factored form. X plus 3 was out in front, and now up on top I have x squared minus x minus 20. This part right here came from what's up on top. This part I need to factor so that I can find my x-intercepts. But this is quadratic. I can factor this using the x and the box. Can I use the shortcut on this one?
Yes.
Yes, I can. So I need 2 numbers that multiply to give me what?
20, negative 20.
Multiplies to negative 20
And negative 1.
and adds to negative 1. What do you know of that'll multiply to negative 20 but adds to negative 1? How much? 20 and 1? Negative 5 and a positive 4. So I'm going to have x minus 5, x plus 4. We were given that x plus 3 at the beginning. We were told that that was a factor. Here is my factored form. How do I take this factored form now and write down my roots? Set them each equal to 0. So I would have x plus 3 equals 0, x minus 5 equals 0, and x plus 4 equals 0. So where are my x-intercepts?
-3, 5, and -4.
-3, 5, and -4. I can use that information now to make a very simple sketch. 1, 2, 3, 4. There would be one here, 1 here. 1, 2, 3, 4, 5. What would the right side be doing? Going up, positive leading coefficient. What's our degree? 3. So what's the left side doing? Odd, so opposite, which means going down. Do any of our factors have little numbers next to them? Nope, so it's going to go through them like lines. And then I just need to connect them in this middle one. Very basic sketch. Let's try another one like this. You guys ready to try this process of long division again? What's the part that's going to go out front on the next problem? 2x minus 3 goes out front. Factors go in the front. So 2x minus 3. What's going to go underneath the long division sign? The long part. 2x cubed minus 3x squared minus 8x plus 12. What are going to be the first two things that I compare? Yep. 2x cubed and what was the other piece of it? 2x. 2x cubed divided by 2x. What's going to happen to the 2's there? There's going to cancel. So what would I have? X squared. X squared goes up on top. We'll get to that guy in a minute. Okay, x squared. What do I do with that x squared now? Put it up on top. After it's up on top, distribute both pieces. What's x squared times 2x? 2x cubed. Because it's x squared times x. Do these two front pieces match? Yes, they need to match. If they don't match right there, you've made a mistake. What's x squared times -3? Close. -3x squared. What are we going to do now to both pieces? Subtract them. Well, this one, I just put a minus sign in front of it to subtract. The other one's going to change to addition. We're going to change both signs. What happens to both pieces?
Cancel.
On this one, they both cancel. If they both cancel, that's okay. I just bring down what I have left over. -8x plus 12. And then I start all over again. What are the things I want to compare this time? 2x and -8x. So -8x divided by 2x. What would happen to the x's there? X's are going to cancel. So what's -8 divided by 2? -4. This is what goes up on top. What do I do with that -4 now? I distribute that. -4 times 2x. -8x. -4 times -3. +12. And then what do I do to both of those things? Yeah, they're both going to change signs so that -8x becomes positive, but the 12 becomes a negative. Both signs will change. They both cancel out, which means I have a remainder of 0. So from the beginning, I had 2x minus 3. That's one of the factors. What did I just learn from doing this long division now? What'd you say? It's on the line. X squared minus 4. That came from what's up on top. That's part of the factors here. But I need to finish factoring that so that I know where my x-intercepts are. Can I use the shortcut on this? Yeah. Difference of perfect squares. Nice identification there. Difference of 2 perfect squares. So how many factors do we get when it's a difference of 2 perfect squares? 2. What's the only difference between those factors? Plus and minus. How do I figure out what's going to go in there? It's not going to be x squared in both because x squared times x squared is not x squared. Yes, we're going to square root this so they each get x. And we're going to square root the 4. Square root of 4 is 2. And then I still have that factor that they gave me at the beginning, 2x minus 3. Here is my fully factored form. How do I take this fully factored form now and find my roots? Set them equal to 0. So 2x minus 3 equals 0. X plus 2 equals 0. X minus 2 equals 0. Give me 2 of the roots, the easy ones. Negative 2 and positive 2. Why did I say those were the easy ones? Why aren't they all 3 easy? Yep, add 3 to both sides first. 2x equals 3. Then we divide both sides by 2. We get a fraction. Yep, x equals 3 over 2. Or you can write that in its decimal form, which is 1.5. Can I make a sketch of this? Yeah. 1, 2, 1. Well, I'm going to make that a little further since it's not going very far. 1 at positive 2, 1 at negative 2. And one of them at 1.5. Yep, right there. What's the right side doing? Going up because my leading coefficient is positive. What's the left side doing? Going down. Are any of these going to bounce like a parabola? Nope. So I just come over and connect it to that 1 in the middle. Let's practice one last one like this. You guys are doing really, really good with this. This polynomial long division can be a little confusing, but the more we practice it, the process doesn't change. What's going to go on the outside of this next example? 4x minus 1. This goes out front. All right, so 4x minus 1. Underneath my big, long division sign, I take the big, long polynomial, 12x cubed plus 17x squared plus 3x minus 2. What are the first 2 things I'm going to compare?
4x and 12x.
Yep, 4x and 12x cubed. So 12x cubed divided by 4x.
You get 3x.
Yep, 3x squared goes up on top. What do I do with that 3x squared now? Distribute it. What do I get when I distribute that? 12x cubed and negative 3x squared. What's going to happen to both of my signs? They're going to flip because we're going to subtract. I have two things to subtract here. I subtract this just by putting a minus, but I subtract something that already has a minus by turning it into a plus. What happens to my 12x cubes? Cancel out. What next? 17x squared, positive 3x squared. Is it going to be what? Not to the fourth. We're just adding those front pieces. 20x. Not to the fourth power. Keep your exponent the same. Yep, 20x squared. Bring down these other pieces. The only time my exponent can change is if I'm multiplying or dividing things. If I'm just adding or subtracting, the exponent will stay the same. What do I want to do next?
17x squared and 4.
Close. Not 17, but 20. Because I had to combine those terms first. 20x squared, we're going to divide that by 4x. 5x. This goes up on top. Is that a positive or a negative 5x? Positive, so I put plus 5x. What do I do with that now? Distribute it. 5x times 4x. 20x squared. Negative 5x. What happens to both of my signs now? Both signs flip. So that 20x squared becomes a negative, and the negative 5x becomes a positive. What happens to my 20x squareds? Cancel out. 5x and 3x. Yep, I have 8x. Remember, my exponents only change when I multiply or divide. So since we're just adding these together, it's going to keep its exponent. And I'm going to bring down this minus 2. Last time through, what am I comparing? 8x and 4x. That is 2. Because my x's are going to cancel out. Oh, I wrote 2 there instead of x. X's are going to cancel, and I have just a 2 left. That goes up on top. Positive 2 or negative 2? Positive, so I put plus 2. And then what do I do with that? Distribute. What do I get when I distribute it? 8x and negative 2. What happens to both signs? Yep. This becomes a negative. This becomes a positive. They're both going to cancel. So I get a remainder of 0. All right, so let's write down what we know so far. What was the factor they gave me at the beginning? 4x minus 1. And what did I just get up on top now?
3x squared plus 5x.
Yes, 3x squared plus 5x plus 2. This came from up on top here. What am I going to do with this piece? We have to factor this guy. Can I use my shortcut on that one? No. So I need to do the whole thing. Box with an x. My a goes here, so that's where my 3x squared goes. C goes down here, so that's where the 2 goes. I have to multiply a and c together. What do I get when I multiply a and c together? 6. 2 numbers that multiply to 6, but add up to what? What multiplies to 6 but adds to 5? 3 times 2. So I have 3x and 2x. Looking at just 2 boxes at a time now. What's the biggest thing I can take out of 3x squared and 2x? Just an x. What about 3x and 2? 1. Positive 1 or negative 1? Positive. There's one of my factors that I was looking for. What about 3x squared and 3x? Not just x. 3x. I can take a 3 out of both pieces. 2x and 2? 2. Positive or negative 2? Positive. So fully factored, I have 4x minus 1. I have x plus 1. And I have 3x plus 2. How do I find my roots now? Set them each equal to 0. Easy one is negative 1. There we go. X equals negative 1. 4x minus 1 equals 0. What would that one be? 1/4. We add the 1 to both sides. 4x equals 1, and then divide both sides by 4. So we get 1/4. Yes, or 0.25. What about the other messy one? Negative 2 over 3. Beautiful. So I could get a very basic sketch here, negative 1, negative 2/3. If I put that in my calculator, that's negative 0. What? Negative 0.6 repeating. So that's going to be pretty close to the negative 1. 1/4 you said was the same as what? 0.25. That's not very positive at all. What's the right side doing? Up or down? Where do I look? Leading coefficient. What is my leading coefficient at the very beginning? Look right here. Positive. So right side goes up. Left side goes down. Going to be opposite. Why is it opposite? Degree is 3, which is odd. Yep. Do any of these bounce like a parabola? No. We can look a couple different places. You can go all the way back to the beginning, because what we have down here, the fully factored form, is just another way of writing that original one. So you can look all the way back at the beginning for your leading coefficient. You could also look in your factors. Out in front of this whole thing, we didn't pull out a GCF, did we? So that's just a positive 1 out there. And then our degree is right here. Very nice work today, guys. You have a homework assignment that's due Wednesday morning, so we have tomorrow to practice yet. We're going to learn something tomorrow called synthetic division. I will unfortunately not be here because my daughter has a doctor's appointment tomorrow that I have to take her to. There will be a video on synthetic division. If you don't like synthetic division, it's not required. Long division will work on all the problems. So you can just keep practicing what we did today. I will post a video about synthetic division. Please go ahead and watch through that because some people prefer synthetic division over long division. All right? Have a fantastic rest of your day, and I will see you guys on Wednesday.